Mm-hmm.
Hi, good evening, everybody. My name is Bruce McCallum, and I'm in Victoria, BC. I'm a realtor with DFH Real Estate, and welcome to tonight's Victoria Home Chat program. I think you're really going to enjoy it. But before we get started, I just wanted to tell you what it's all about. I started this webinar series about a month ago, and it's here to help inform home buyers and sellers. We don't have any sales pitches. We don't have any hype. It's just providing good information that you can use to purchase or sell your home. It's filled with interaction. We've got live Q&A scheduled tonight, and this is a weekly series, and we broadcast every Thursday at 8 p.m. If a little housekeeping, for you who have questions during the program, if you see on your screen this white box, and I've said here, click on the empty box and type in your question. When you do that, it'll come to me, and then I can ask that question of our guest presenter, Rob, tonight, and then we can move on, and we'll show you some exciting things too. So tonight on our program, we've got Rob Bernhard of Bernhard Contracting. And I met Rob, I think it was a couple weeks ago, when the realtors at my company had a tour of this home. Now, this is not your normal home. It's called a passive home, and it's extremely energy efficient. And this is why we're here tonight. As you can see behind me, it's a very, very modern design. It's a beautiful home. They're just in the final phases of completing it. But it's a super energy efficient home. Why? Well, we're going to talk about that tonight. We're going to show you some features, and Rob's going to walk around a little bit and point out some of these unique things. So, Rob, I'm happy to have you here tonight. This is Rob. Move in here, Rob.
All right.
And
a little closer, Bruce.
Sure. Come on in here. And, you know, I think one of the big questions people have is, you know, we call this a passive house, but you know, what do you mean by that? What is a passive house?
Well, it is really just a arguably unsatisfactory translation of a German term. It is, in fact, neither passive nor necessarily a house. What it means is it's a building that uses fewer active mechanical systems, not no systems, but fewer systems than conventional construction. And it applies to any type of building, whether it be a residential building, multi-residential building, commercial institutional building. It applies to all types. So the word house, H-A-U-S in German, means building, not house.
Okay.
But, that's the origin of the term. And that's a very common question that we get on this side of the Atlantic.
Right.
In Europe, it is in fact a very common building standard. In some jurisdictions, it's the building code now. Europe-wide has decided that it will be the building code before too long. They have a variety of public policy reasons for doing that, and they are quite determined to achieve their energy goals as a continent, and they're working towards that, and they see modifying the building standards as being an important way of doing it. So what a passive house is it simply, as this slide indicates, a very energy efficient building that requires such a small amount of heat that it's heated mainly by passive sources, such as incoming sunlight through windows, specialized high-quality windows, but windows, and in what we call internal heat gains, things like appliances or people and that sort of thing giving off heat within the building.
So as we're sitting here, all the heat that we're generating and all the lights and everything else is contributing to the overall warmth of the air that we were in.
Yes, I think the average human puts out, I've forgotten what it is, 300, 500 watts of energy per hour or something like that, and that's just kept its energy in the building. It's warm. And you notice that if you get a lot of people in a room, the room warms up quickly.
Right.
If you have a very energy efficient building, it'll warm up even faster.
Right.
So the building is very well constructed in terms of the well-insulated.
Do you mind if I just, as you're talking here, I'm just going to very carefully show the room.
Sure. No, that's right. Pan around behind us. And so the building envelope is very well insulated. There's high-quality windows and doors. And in that way, the energy that is and the heat that's in the building stays in the building. And then the air quality is maintained by having a very efficient mechanical ventilation system called a heat recovery ventilation system.
Mm-hmm.
And that's the other key component. You build a high-quality building envelope, and then you maintain superior indoor air quality by exchanging the air on a regular basis through the heat recovery ventilation system. Uh-huh. And what a heat recovery ventilation system or an HRV does is it brings in fresh air all the time, but as the cool outside air is coming in, it's run through almost like little straws right beside the outgoing warm air, the exhaust air. And the heat from the outgoing warm air is transferred just by conduction to the cold air that's coming in. And because it's so carefully engineered and designed, they get almost all of the heat out of the exhaust air before it goes out. So you're actually exhausting cold air and you're bringing in warm air, and that exchange of heat is free.
Amazing, amazing. So let's move on to the next slide here. This is a picture of the outside, and I think it was taken a few weeks ago, wasn't it?
It was taken a few weeks ago. There's been some work done since then, and so that's a few weeks, just the eastern aspect of the home from the backyard, really. And then that building, although from the outside it may not look remarkable, and from the outside it could look like any other building on the block, but this graph illustrates the real difference between this building and other buildings. The multicolored column on the left of this slide represents the amount of energy used in the average house that's out there in the Canadian market. And so it's somewhere close to 300 kilowatt hours per year, per meter, and of living space. New buildings, that would be the new buildings built and often considered to be energy efficient and so on, are still using almost 200 kilowatt hours.
So this is the column that we're looking at in the middle.
That's right, the middle column.
The middle column.
And
okay.
the red part of those two graphs, of the three graphs actually, represents the heating energy, so the energy used for heat. And then we come finally to the column on the right, the passive house amount of energy that's used. And you can see how it's just dramatically less. It's about 90% less than the average building out there. So we're not trying to reduce energy consumption by 10 or 20%. We're reducing it by 90%.
So does this mean that we're not really dealing with a furnace per se?
This building, in fact, doesn't have a furnace.
It doesn't have a furnace.
And if the energy requirement for heating is that low, then the heat can be provided by a small supplemental heat source, and we've included just a simple hot water coil in the HRV supply duct. It runs off the hot water tank. Right. So what we've done is eliminated the furnace.
Now in Victoria, during the winters it gets down to, well, let's say 40 degrees Fahrenheit. If this were to be implemented in Toronto or something, would this work?
Yes, it works all over, and in fact, climates like Vancouver, Victoria aren't particularly easy because it's dark and wet. And if it were minus 20 Celsius and sunny, that's quite an easy condition to heat because the solar gain is really quite dramatic. So, you know, I don't know which is a more challenging condition for a passive house, minus 20 and sunny or plus 5 and dark and rainy. You know, it might be the plus 5 and dark and rainy. So,
interesting. Yeah. Okay.
Then the other feature of a passive house, apart from the energy efficiency, is the air tightness. And this is a concept that may require some explanation. But the air tightness is a measure of how much air can escape from the inside through to the outside of the house, the external walls, when all the doors and windows are closed. And a house built before 1945, they'll often have, like in the column on the right, I think it goes up to about 10 air changes per hour there. So if you were to put a blower, which they do, it's called a blower door test. They put a blower in the door and seal the building up as best as it can be sealed up. And then they measure the amount of air going into the building, that they blow into the building, and they maintain a constant pressure and see how quickly that goes down in pressure. And so the whole building volume turns over about 10 times per hour. It's so leaky. So the average home is down to about 6 air changes per hour. The new home in 2010, prior to the current building code that just came into effect, is down to around 4 or 5. An R2000 home, considered, it's an older standard that's still around, but it was considered an extraordinarily airtight building and energy efficient. That's what it was designed to be, and it is. But it's at about 1.6 air changes per hour to meet the R2000 standard. Passive house is about 1/3 of that. It's 0.6. So, and this building that we're in right now is much lower than the passive standard. It's about 0.31. So, you know, it is easily about 6, well, not easily, but about 6 times as airtight as a R2000 house.
Now, I kind of warned you before I would ask you this question, Rob. You know, people out there are probably wondering, hey, airtight means airtight. And how in the world are we getting fresh air into the home? And this is done through that HRV, heat recovery ventilator, right?
That's right.
And maybe I can show the audience just really quickly. Maybe you could point up to it. I think I see one over there, don't I?
There's 2 actually on each side of those pendant lights.
Yeah, if I can move up here just a little bit. Can you see that, Rob, there in the screen?
You can see just 2 little circles in the ceiling. There's the 2 pendant lights hanging down, and just on the outside of each light, there's a little, it's actually an exhaust duct. Those are 2 exhaust ducts. But that's all they look like, exhaust or intake.
You know, now that I think of it, Rob, too, I was asking you before, this is the kitchen that we're looking at.
Yes.
And I said, well, I don't see a range hood. So what do you do about that?
Well, the microwave that you can see right over where the range
If you wanted to show us, too, if you wanted to show us.
Missing, actually. Does the microphone pick us up?
Yeah, I think it will.
Okay.
Just talk a little bit louder. But I'll kind of follow you over there.
The range will go in here, and there's a microwave over the range light with a high-quality charcoal recirculating fan in it. So there's a charcoal filter here, and it will recirculate the air, take the grease or smoke out of it, put the air out here, and then the HRV exhaust ducts, which are up there, will keep the kitchen air exhausting and flowing out this way.
Amazing.
So that's all it is. There's no separate
and it's moving
exhaust. It's all built through the HRV.
And like you said before, it's moving the air fast enough so it can clear whatever cooking smells out.
That's right.
Out of the air. It's moving quick enough.
That's right.
Okay, that's great.
No, it's a very high flow rate.
Okay.
Lots of fresh air.
All right.
Now, the question is sometimes given to us, why did we do this?
Yeah.
And why did we build a passive home? And in our minds, there's a couple of reasons to do it. And we're general contractors and in the business of building. And there's the 2 reasons are really, number one, it's fundamentally the right thing to do. It's a sustainable way of building. It, in our view, is a building standard typical of what will be there in the future. It's for a whole variety of reasons. It's the direction we think the construction industry is going to go, and it allows the construction sector to be part of the climate change solution rather than part of the problem. So it's the right thing to do. It's also, in our view, fundamentally good for business. Buildings that are built to this standard typically have a higher market value. They sell quicker. They're less expensive to operate. They have fewer mechanical systems to maintain, less energy bills to pay. So they tend to be good for business. And anywhere where the sales are tracked, data is gathered, that's the case.
And I'm assuming here, I don't know the answer, that the way it's built means it's built very, very well. And the life expectancy is probably longer than a traditional.
It is, because you've got, actually the air tightness is part of that. Moisture doesn't get from the inside of the moist interior air doesn't penetrate the walls,
Right.
because, at least not anywhere near to the extent that it does in most construction, because the walls are airtight. So the moisture doesn't have the capacity to get into the walls and create problems. You tend to get a durable envelope. And with passive house design, the sustainability is what we call baked in rather than sprinkled on. It begins with the design itself and how you plan the building and plan the wall assemblies and so on. And then that's how you get the efficiency. It's not by sprinkling on the latest gadgets and heat pumps or whatever after the fact. You don't start with a conventional design and then try to add technology to make it more efficient. So adding the technology or sprinkling on can be really quite expensive. Building a good envelope isn't.
Okay. And so what does this all add up to?
Well, the standard, when you build a home that is this energy efficient, a number of consequences flow from that. Number one, you've got superior thermal comfort. With this quality of windows and doors, the windows are not cold. You can sit beside them and it's the same temperature beside them as it would be in the center of the room, for example. And
well, you know, it's interesting. I don't mean to interrupt, but it's interesting. As I'm sitting here, I'm in my stocking feet, and I'm noticing that my feet are perfectly warm. There's no cold, hot based on height.
And even on the lower level, the basement level, you'd be in your sock feet there, and there's no in-floor heating, but because the floor slab is so well insulated, it's not cold. It can't get the cold from the ground. It's got the warmth from the room. So it's the same temperature as the room. And so it's that evenness of temperature and the thermal comfort that's there. And with the ventilation system, then you've got superior indoor air quality. And so those two things go along with the energy efficiency. And of course, there's reduced energy costs and fewer mechanical systems to maintain. There is a slight increase in the cost of construction, but it's still often the most affordable way to build, because the increase in construction costs, which we'll talk about more later, are less than the savings that you get. So if you, well, we'll talk about that. Come back to that later, perhaps.
Okay. This is an interesting chart that I'm looking at here, and from what I can tell, it talks about how the sunlight affects the heat.
Yes, this is a drawing from some of our architectural drawings, and it shows that the overhangs that we have on the south face of the building are designed so that they provide shade. The windows are shaded in the summer, but in the winter, when the sun is at a lower angle, the sun comes in through those windows and you get the solar heat gains through the glass. And that's one of the fundamental design principles of a passive house, is you design it so that you capture the sun, the winter sun, but you're shaded in the summer. And it's cool in the summer and warm in the winter. So if we just have a look at the next slide here, I can advance this. We've talked a couple of times about air tightness, and the level of air tightness that's required in a passive house is not achieved in the way that it is in conventional building. What we do is we have a continuous air barrier that's designed into the building from the outset, and it's often a layer of sheathing. It could be OSB, it could be some other wood product, but that layer is on the inside of the main thermal envelope, and then that layer is continuous. It goes right from the floor slab up over through past all stories, across the ceiling and back down to the floor slab on the other side. You can take a pencil and follow it on the drawing all the way around the building and never lift the pencil off the paper. So it is continuous in that way. And then that envelope isn't something that the electricians and the plumbers are allowed to drill holes in. So it's intact, and any seams there are sealed with high quality tape. Then within the openings, the rough openings you create, you put in very high quality windows and doors and make sure that they're well sealed. I referred a moment ago to tapes where the seams are taped, but they're specialized air sealing tapes.
Yeah, I think we have a picture of that later.
That's right.
Would now be a good time to look at the window?
Sure. Here, Bruce is an example.
And I'll bring the camera over here a little bit.
Of the window that we've used. It's actually the first window in North America manufactured to the standard that's required for a passive house. There's many manufacturers in Europe, but we until recently haven't had one. And as luck would have it for us, it was made by Euroline Windows right here in Delta, BC, so it's a very convenient product. But you can see, first of all, that there's 3 panes of glass. I don't know how well that shows. That's showing, I think, better on the image. So they're triple-paned windows. And each pane is separated by what's called a spacer. And the spacer is thermally high performance as well. There's very little conductivity. And the frame itself, you can see there's many cavities. It's a fiberglass UPVC composite, so fiberglass for the strength.
So this outside, it doesn't look as though you have to paint it all.
No, it's a special foil they put over it. You have a selection of colors and so on that comes in. And this is the color we wanted on the exterior of our building. So yeah, in places, not everywhere. But the larger cavities that you see inside the frame itself are actually insulated. So there's sleeves of insulation that go in there, and the windows that we install have that insulation in there. And this is a section of an opening window, so you can see the part that would open is right there. And there's 3 gaskets, rubber gaskets, that are providing the water.
I think I can see them in there.
There's 1, 2, and 3.
Right.
And the windows, when they close, there's a tilt and turn window, and there's a series of pins all around the frame that turn and then lock and suck the whole window.
And I think I saw one of those over here.
Yes, there's an open window there.
If we kind of go over here a little bit, and you can show us this window.
All right. There's a window here. And this is the pin that I was talking about. So when you turn, you can see it moving a little bit there as I turn the handle. And but the windows are tilt and turn, which is typical in Europe. This is a locked position. Turn the handle like this, it opens. There's a normal window does. And then turn the handle up, and it tilts. So the doors can do that, and the windows can do it.
Fantastic. Okay, that's good. All right.
So the quality of the windows and doors is key. And then after we had the windows and doors installed and we built the walls and had them insulated and so on, we went around with a thermal imaging camera and we looked for leaks. You could put a little air pressure in there with a blower door and look to see where the cold air is coming in.
And I think we have an image of that, don't we?
We do. If we just go along to I think it's...
well, that's the tape.
That's the tape sealing the joints between the OSB.
And that's a special tape you mentioned.
It is. It's special air sealing tape. It's very long lasting. It's got great elasticity. As the building sort of moves and shifts over time, that tape just stretches and keeps sticking. It's an amazing product.
This shows the windows.
Yeah.
Now this is an actual photograph that you took a little while ago, and I think this is the lower level, isn't it?
That's right. Yeah. It's the lower level and the amount of glazing that's there.
Yeah.
And the construction is now significantly further along, but that's the way it looks. And it's mentioning just some of the details on the windows.
Very bright, even though it's a lower level. It's very bright.
Yes. Yeah. Well, that's something we wanted. That isn't a trademark of Passive House, but it's something we wanted, and certainly something that is possible.
Well, it doesn't feel like a lower level. It feels like a beautiful living space.
We call it the garden level because you can see it's still sort of under construction, but that patio that's out there and maybe a garden, and big lot and lawn. So, Now there's the thermal imaging camera shot that we mentioned earlier. And that's a couple of images taken. The upper one, you see the bright yellow circle there. It's not the rising moon. It's actually the HRV duct before there was an HRV hooked up to it. So it's got the outside cold air, I believe it was. I think it was colder outside that day. Showing, I can just check that. Yes, it's a little less than 1 degree colder outside on that particular day.
So anything yellow is cooler.
On this image, yes.
Right.
Yeah. And you can see, so that duct is outside air because it's obviously just a hole in the wall. Mm-hmm. And this is quite an unfinished building that's taken. It's like an X-ray. But there's also some pale yellow bars beside that round circle, and those are actually some of the wood framing, because wood doesn't insulate as well as insulation, so you can see some of the wood framing there. And the lower slide, that's mostly in blues and yellows, is an image of the exterior of the building, because you walk around the interior and the exterior. We'd really recommend anyone that's inspecting a home use a thermal imaging camera. It's amazing what it'll show you. It can show you gaps in the insulation. It can show you all kinds of things. So it's really money well spent. It's an amazing tool. Now, here's just a snapshot of one of our crew members building what we call the service cavity. You can see behind that 2x4 is the OSB layer. That's the inside of our main wall. Yeah, we call it the thermal envelope. You can see the green air sealing tape around there.
So this you cannot poke through. This is
that's the layer. That's the air barrier, vapor barrier that nobody's allowed to touch without our written permission, sort of thing.
Right.
And then inside that, we build a very lightweight 2x4 frame wall. It's not structural, so it's sort of quick, easy, inexpensive to build. And the plumbers and electricians are allowed to do whatever they like to that wall. And they can run wires and pipes wherever they like. So, and then after they finish, we go and put some insulation in that wall as well. But we've maintained the air barrier in that way. So when we build to this standard, we get heat sources from energy sources from a number of places. And the main source of energy, I think as I mentioned earlier, is the solar heat gain through the windows. The secondary source of energy is the internal heat gains from appliances, people, that sort of thing. And then for our other heat, we've used natural gas, so we've got a really efficient natural gas condensing boiler that runs an indirect hot water tank. And it's that boiler that also runs the hot water or the hydronic coil that goes into our HRV supply lines. So that's how we've heated the hot water and the space heating in the building. And then we use electricity for other needs, lights and so on. So it's all, the electricity is just totally conventional. Now, with passive house construction, there is an increase in construction costs, but there's also decreases. So some items go up in terms of your budget and other items go down. So the areas where one realizes savings are typically in the mechanical systems. And that really is the whole concept of the passive house design standard. The building physicists who developed the standard looked for a means and studied how one can increase building energy efficiency to the point where it allows you to begin shedding costs. So normally, as building efficiency is increased, costs increase, but at some point you can eliminate a furnace, for example, eliminate other things, and they decide, all right, at that point, that's how efficient we should be. Anything more becomes cost prohibitive. So we are able to eliminate in a passive house in-floor heating. We don't need the radiators under the windows. You need some heat source somewhere, but it doesn't need to be under the windows. You don't need to be running ducts to the extremities, the outside walls of the building. And because you've got the exhaust from the kitchen built into the HRV, you don't need makeup air for the kitchen. If you've got a modern airtight house, often with a large range hood, then they need a make-up air supply for the kitchen, and that's eliminated here. Things like bathroom fans we don't have. Again, the HRV is running constantly in the bathroom and provides actually a higher exhaust rate than almost any bathroom fan.
And it's silent too. We're sitting here and I cannot hear a thing.
You should not hear it. And I keep likening it to walking into a good hotel bathroom, and you look for the bathroom fan, it doesn't exist, and you can't hear anything, and you just think, oh dear, this isn't going to work. But it does.
It does.
And
it
the
really
reason
does.
is that they have a good ventilation system.
Yeah.
It's properly designed and
Yeah.
silent. So, so we don't need those sort of exhaust systems in the kitchen and in the bathrooms. And also, if the home is properly designed in our climate, there should be no need for mechanical cooling. We consider a need for air conditioning to be a design weakness, that it's possible to design away the need for air conditioning. Provide for summer shade, design that sort of thing into the building. And obviously the furnace we've talked about, and the slide mentions consumer bathroom vents again. So here's a chart just outlining some of the costs in this particular case, and we compared this building to another very similar style of building in this area being built at the same time that offered the same sort of indoor air quality and thermal comfort. But they did it in the traditional way. They had a heat recovery ventilation, but just a lower quality than what we have, less efficient. And they provided the thermal comfort through in-floor heating, radiators under the windows, that sort of thing. They had make-up air in the kitchen. And so they spent much, much more on those systems than we did. We spent more on our windows. We spent a little bit more on framing, on insulation. And end of the day, our costs were about $31,000 higher than their costs on a $740,000 budget in that range. So it's not a big difference. And,
but the savings over time will more than pay for that.
Exactly. And it in fact isn't even over time that it pays for it, because if we take that incremental cost of construction, add it to the mortgage, then the cost of living in that residence from day one is cheaper, because the savings exceed the increase in the mortgage payment. So the thing we like about it as builders is it's really a transfer of wealth from the energy companies to the construction sector. And that has to be a good thing.
And so we're looking here at a total cost of living per month, passive construction $209, conventional $260.
Yes.
It's quite a difference.
Yeah. But look at the energy cost.
Yeah.
The passive house is $65 a month.
Yeah.
The conventional is $210. This is a modern, normally considered to be energy efficient home, still at about that level. They're spending significantly more on mechanical and maintenance systems. And add up what it costs to maintain a furnace and repair it, and the floor heating and all these other features. And then, of course, the passive house will have the larger mortgage, and you net it all out, and it ends up being cheaper to live in the passive house.
Impressive. And better for the environment, too.
Yes. Yeah.
Well, this is great. Rob, we're going to have a little Q&A here. For those people that are watching, go back to that little box there, and you can type in your questions, and it'll come up on my screen. But I wrote down some questions as well while we're waiting. And one of the ones I had for Rob is can this be applied to a new reno? Let's say somebody's bought a house inexpensively and they want to do a renovation. What technologies do you have here that they could implement in their renovation?
Well, Bruce, it can be applied to renovations. There's actually, within the Passive House standard, a separate standard that is intended specifically for renovations. But regardless of if one is pursuing that standard or not, if you wish to take an older building and make it really energy efficient, that's possible. And but it isn't always economically justifiable. So one would want to have a building that's in a good location, that is a good building that has some real value. It might have heritage value. It might just be well built or well designed. And but it typically requires stripping it down to its bones and then starting new. It's not a matter of just putting in some better windows.
You know, one thing that comes to mind is probably that envelope.
Yes.
That is so important.
Yes.
And that's why you have to get down to the bones of it.
It's really quite important you get down to the bones. So to do a renovation to this standard, it's almost like a once-in-a-lifetime renewal of a building. You end up with a virtually new building that's a completely different building in terms of its comfort and its operating costs and that kind of thing. But it's a significant investment. You can always do less, but to do it to that standard is an investment.
Another question, and I think we covered it before, is how does the lower level stay so warm? I think that in most houses, if you go down to, I'm not going to say a basement level, but a lower level, there's a considerable difference in how can I say, comfort, thermal comfort. And here, I didn't notice any difference at all, and it's really due to, well, the envelope, of course, but also the floors are so well insulated. Is that right?
That's right.
What did you do over the concrete on the floors? Wasn't there very thick insulation?
Yes, there is. And cold always comes from somewhere. So if you put insulation between the cold and where you're living, and make sure it's a continuous layer of insulation, the cold can't come in.
Right.
And so we used EPS foam or geofoam around the concrete, on the outside of the concrete. And we put a good thickness around there. And the result is that the concrete foundation is not cold. And in the winter, it absorbs the warmth of the indoor air because it's isolated from the cold ground. And it becomes room temperature.
One question that I had is, in Victoria here, we have a series of buildings that were built a couple of years ago called Dockside Green. And they came on the market touting their energy efficiency. In terms of energy efficiency, how does this compare to Dockside Green?
This would be dramatically better. It's really a totally different level. The Dockside Green is a great development done to the LEED Platinum standard, and LEED is in our view, a tremendous building standard. It's more holistic than Passive House. Passive House is very targeted. Passive House is just building science, so it's science-based, and then it's economically driven. And in our view, it's foundational, that it's a good starting point for other building standards. So if you want to be net zero, LEED Platinum, whatever building standards you may be interested in, if you start with a Passive House standard, it becomes much, much easier to meet the other standards. Our experience is that if you begin with a sustainable building site and use normal, responsible building practices and build to the Passive House standard, you shouldn't have any difficulty meeting LEED Platinum standards.
And I think most people have heard LEED.
Yes.
Is it fair to say that this is probably one of the most energy efficient homes in Canada?
It'd be one of the most. There's other Passive Houses. It'll be the most energy efficient home on Vancouver Island at the moment. Hopefully not for too long. And it's only other Passive Houses that would be in this category of energy efficiency.
Another question: are there grants for any of this? If somebody wants to get involved with building a Passive House, are there certain grants that are available?
There are, but the grants aren't available specifically for Passive Houses. The grants, in our view, aren't substantial enough to really impact the decision of whether or not to build. They're always appreciated and always nice, but they're in the realm of a few $1,000s.
Okay.
What may be more relevant for homeowners is that this standard of construction helps communities achieve their policy objectives and their environmental objectives and so on. So it may be easier to get planning approvals, that type of thing. You'll often find local government is very supportive of this.
Great. And I'm assuming Saanich, the district that we're in, was very supportive of your efforts.
Yes.
Yeah, that's great. Okay. Well, I think that's we're coming up to the end of the program here. I'm just going to advance to one more slide that Rob has got here that might be of interest to our audience, and this is a publication. And Rob, tell us just a little bit about this.
As saying a few minutes ago, Bruce, that this construction standard helps communities achieve their policy objectives in terms of climate change and other factors as well. And the City of Vancouver has published a design toolkit, a passive design toolkit for homes. And it's an excellent booklet that explains a lot of the aspects of passive house design. And I'd recommend it to anyone. It's available on the City of Vancouver website. You can go to the website and download it. And I think most people that are interested in energy efficient construction would learn a lot by reading it.
Okay. And they can probably Google this just by typing it in?
Yeah, go to City of Vancouver, search the City of Vancouver website, and it's the Passive House Design Toolkit.
Okay. And I've put your phone number up here too. I hope you don't mind. People might be calling you about more information about this.
Yeah.
Well, listen, I just want to thank you. I'll get into the scene here. I just want to thank you again, Rob, for joining me tonight. And as I look around this house, I'm just absolutely thrilled for what you've done. It's a beautiful house. It's very, very comfortable, and I thoroughly enjoyed being here. So thank you very much.
Thank you for coming, Bruce. Okay. Appreciated the opportunity.
Great. Okay, well, I hope you've enjoyed our broadcast tonight. I've enjoyed it being here in the Passive House, and I'd love to come back again if I could in the wintertime to test the thermal envelope if I could. But I've thoroughly enjoyed this. The next program for Victoria Home Chat is May 23rd, 8 o'clock, and we're going to be talking about first-time home buyers and what kind of tips are available for them. So please join me. I'm going to have a financial mortgage person from TD Bank join us, and it should be a really good program. So if you know anybody who's a first-time home buyer, be sure to go to Victoria Home Chat. You can see the website down there, victoriahomechat.com. And again, May 23rd. So thank you very much for joining us tonight. And if you want to see this in its full length, I will be having recordings available for this program and all the programs as well. So thank you very much, and this is Victoria Home Chat. Thanks.